Thank you for coming, and welcome to another episode of Micrel TV. My name is Brian Huffman. I'm a product definer here at Micrel. In this tutorial, I'm going to show you how to program the MIC7400 using our graphical user interface. The MIC7400 is the newest part in our small form factor solution portfolio and is one of the most integrated, high-power, multiple output power management ICs on the market today. What makes this power management IC different from our competitors? It is that it has 5 3-amp synchronous buck outputs and 1 boost, all in a 4.5 by 4.5 millimeter package, making it one of the highest watts per square inch PMICs on the market today. The key feature of the MIC7400 is the ability to configure the part through a graphical user interface. This means instead of using onboard resistors and capacitors to set the output voltages, soft start ramps, and sequencing, you can just click on a series of icons and checkboxes. In this tutorial, I will show you how to install the MIC7400 GUI, configure the part, and then save the file. So, let's get started. The first thing you'll need to do is download the GUI. To download the GUI, go to the Micrel website at www.micrel.com. Then type in MIC7400 into the search field. Then click the search button. Select the first result, and this will take you to the Micrel 7400 webpage. To download the GUI, select the software package hotkey. Here you have an option to either open the file or save it to the hard drive. In this case, I'm going to save it to the hard drive. I'm going to select this and then extract the data. And then I click OK. After the file is decompressed, go to the place where the extraction software, unzip software, placed the file. Click the MIC74 install icon. Click next. Click next. Click next. Click yes. And that's all there is to installing it. Before you launch the GUI, the USB dongle must be connected to the PC by the USB cable. The dongle must be plugged into the 7400 evaluation board, and finally then power can be applied to the board. The USB dongle has a micro switch with 2 positions, I2C and normal. Make sure that the switch is in the I2C or left position. Next, connect the USB cable from the PC to the USB dongle. Otherwise, you will get a failed to detect FTDI device error message when you launch the GUI. Now plug the dongle into the evaluation board. Note that pin 1 on the edge connector is the ground pin, which is a square solder pad. The USB dongle needs to be inverted and plugged into the 4-pin socket. It is a good idea to cut off the extra pins. Now turn on the power supply and ramp the input voltage up slowly. To launch the GUI, click on the Windows Start button at the bottom left-hand side of your screen. Click on All Programs and find the Micrel folder. Click on the Micrel folder, click on the Serial Program folder, and then finally click on the 7400 folder. Now, click on the 7400 icon and this will launch the GUI. Now, the next thing you need to do is test to verify the connection between the USB dongle and the computer. To do this, you click on Test. On the bottom of the GUI, you will see Target OK. This indicates that the connection between the PC and the dongle is working. Before you can configure the 7400, you will need to set up the GUI for direct editing. To do this, you click on the Link menu, and then Link Mode, and then finally Direct Editing. Now, it's time to program the part. Every regulator has its own configuration setting where you can set output voltage, current limit, and soft start delay. The global settings like power on reset threshold, startup delay, and power on reset delay are at the top of the window. For the output voltage, the first dial sets the output voltage in normal mode, and the second for standby mode. You can click the up-down arrows to change the output voltage, or you can click and hold on the arrow and move to your desired output voltage location and then release the mouse. By selecting the Register tab, you will notice that Register 5 is associated with output 1 for normal mode. And as you change the output voltage on output 1, you'll notice that the Register 5 changes on the fly. As you change the output voltage level in the GUI, the output voltage of the evaluation board will also change on the fly. The buck outputs can be programmed from 0.8 volts to 3.3, and the boost output can be programmed from 7 to 14. The new register values are stored in a volatile control register or shadow register, but not stored to the EEPROM. To store the data to the EEPROM, click on the Save Configuration button. You'll get a warning to say, are you sure you want to reprogram the part? You select OK. Now, the data is stored in the EEPROM and will not be lost if you re-power up the part. The MIC7400 includes programmable soft start function. The soft start feature forces the output to rise gradually, which limits the inrush current during startup. The soft start ramp can be set from 4 microseconds per step to 512. You can also click the high range setting that you can get to 1024. In the case of a 1.1 volt output, there is approximately 22 steps to go from 0 to 1.1 volts. If each step is 8 microseconds, then it will take about 176 microseconds to reach the program value. The buck regulators have high side current limiting for both normal and standby modes. An overcurrent fault on one output would not disable the remaining outputs. In a fault event, the overcurrent status box will be checked and the power good box will be unchecked. The global power good output is pulled low. The output can be turned back on by recycling the input power or by software control. The current limit can be set from 1.1 amps to 6.1 and half amp increments. The current limit trips off the peak inductor current, not the average current. The current limit setting should be twice your maximum output current specification. The power good mask is used to control the global power good flag. If this box is checked, then the output will not contribute to the overall power good flag. This allows the output to go from normal mode to standby mode without triggering a power good fault. Also, the global power good flag will not be affected by an overcurrent fault. The sequence register allows the outputs to come up in any order. There are 6 time slots that the outputs can be configured to power up in. Each time slot can be programmed for up to 6 regulators to be turned on at the same time or not at all. In this case, you can see here that regulator 1 is in the second slot, regulator 2 is in the fourth slot, regulator 4 comes up first, and regulator 6 comes up last in the last slot. When you're done setting up the IC, click on the Save Configuration button to accept the changes that you've made. This only saves the configuration to the EEPROM. To save the configuration on the computer, go to the File menu, click on Register Settings, and then Save. Type in your file name, and then select Save once again. The configuration is saved in a text file that you can send to MICREL so that we can program your parts at the factory. This covers most of the key features of the MIC7400 GUI. To get more information on the 7400, go to the MyCrel website at www.mycrel.com. I really appreciate the time you took to join me. I would like to hear from you and know what you think. So don't hesitate to contact me at MyCrel if you have any questions. Thank you, and I hope you can join us again on a future MyCrel TV webinar. Have a wonderful day.